Good afternoon, everyone. My name is Richard Heckbert, Senior Plastics Engineer here at Whitman. Today's in-booth demo is about how smart machine technology can compensate for variations in melt viscosity. Whitman is at the leading edge of Industry 4.0. We already have the ability to control the TCU, the dryer, the robot, and all auxiliaries for the work cell right from the machine control. Another facet of Industry 4.0 is smart machine technology. Today's showcase is about HiQ Flow, one smart machine technology that can adjust for variations in viscosity control. Right now, the machine is running a 6 MFI melt flow index polypropylene. John now is going to switch from a 6 MFI to the 11 MFI material. Because the number is increasing on MFI, that means the viscosity is going down. The material is more easier flowing. So we're removing the 6 MFI material. And then once that's done, John's going to go back to the back side of the machine and move into the 11 MFI material. Now, this is a drastic change to change from one MFI to another. You wouldn't normally do this, but this is for demo purposes today. But we do have viscosity variations in the industry. These can come from regrind with the ever-increasing demand for the use of regrind and the increasing demand for the amounts of regrind we're using. Also from material suppliers, batch-to-batch variations. Another possibility could be just from the ambient temperature and humidity fluctuating the viscosity. This material change is going to take about 6 minutes for the material to work through the barrel. So while we're waiting for that, let's get a baseline of where we are now. I just moved to the injection page for the HiQ Flow. Right now, we can see that the machine is actively using the HiQ Flow, and we're right now only making a minor deviation, just adjusting by -3 bar. As we see the material come in about 6 minutes, this number is going to increase. So we're at -4 bar, and we're only adjusting the holding pressure by 1%. The average injection work right now is 420 Newton meters. How can the machine measure and adjust for this viscosity? Viscosity is normally measured using a capillary rheometer. A capillary rheometer has a heated barrel, a plunger, and a weight. The extrudate is then measured in an amount grams per 10 minutes. If we can imagine the injection molding machine, the injection unit is a rheometer. We just lay this rheometer down on its side, and we have an injection unit. We have the hydraulic force, we have a heated barrel, and we can calculate the amount of work it takes to extrude this material out of the barrel. At the start of injection, if I zoom in here, at the start of injection, we have a dead space where we don't make a measurement. This is to allow for the closing of the check ring and any inconsistencies caused by differences in the decompression stroke and the back pressure at the end of metering. We then make the measurement starting in the cross-hatched green area. This is the area where we start to get a nice flat profile on the injection pressure. We then measure up until the end, just before the switchover point, to allow a time to make the calculation and to then give room for the switchover position to adjust by the switchover pressure. This all happens in real time on the same shot. Every shot, we're making this correction and adjusting. Our injection time is 0.25 seconds. That means that we're making this calculation, this measurement and calculation in 0.1 seconds, 0.1 seconds. Let's have a look if we've started to adjust our pressure at all. So I don't know that we're just at 6 minutes yet from the material change, so we still haven't seen any adjustment on the changeover pressure and the holding pressure. I also did want to mention that John also did shut off the color feeder at the same time, so we should get a visual representation when we start having the material, the new material, introduced to the mold. So it should go from the red color to the clear color. So HiQ Flow is very easy to set up. All we have to do is we turn on the HiQ Flow. The machine automatically measures and determines where it should start recording, and then takes reference shots. It takes about 10 reference shots, and from these reference shots, we know if something has changed. So I think we're starting to see the material coming through now. The correction for changeover pressure is starting to move up. We're at -5 bar. Now, because we're introducing a material that's more easy flowing, the viscosity has gone down, the material is more easier flowing. That means that the amount of work it took to inject the material into the mold is less. Because it's less, the machine is going to back off the transfer pressure and back off the holding pressure. Thereby, we're keeping the weight inside the mold the same. We're trying to inject the same amount of material into the mold from each shot, even with the difference in viscosity on the material. So we're starting to see the material come through now. We're at -7 bar. Now we're at -11 bar that we've adjusted the switch over. So if I go to the holding page, we can see that I have set 450 bar, but the machine is now dropping the switch over down to 433 bar. So we're backing up that changeover position. If I go to the quality table, we're starting to move our changeover volume up. We're up to 14 millimeters. And the work is decreasing. So the injection work, we were running about 432. Now we're down at 412 on the last cycle. If I check the holding pressure, I have set 310 bar. The machine has decreased this by -0.5%. And if I look at the holding pressure page, we're holding only 309 bar instead of the 310 set. If I go to my envelope page, this is my injection pressure over the entire injection stroke, including holding pressure. We can see that the curve is starting to move down as the material is more easy to inject and it requires less injection pressure. Back to HiQ Flow. We've now removed -19 bar off of the holding pressure and -1.5% on the holding pressure. So a couple more cycles. Now we're at -25 bar, and we've taken 2% off of the holding pressure. So if I go back to here, we're holding with 304 bar instead of the 310 that is set on the holding page. And our transfer pressure, instead of 450 that's set, we're only transferring at 424 bar. And from that, we can continue to watch this as we conclude the in-booth demo. This will continue to fall down. And as we reintroduce the 6 MFI material, this will work back to 0. But I thank you for your attention and enjoy the rest of the show.